I welcome you back for the continue of my previous class, that was force and laws of motion. Force and laws of motion, we have discussed the nature of the force first, how what is force and all about it, and its proper definition, physics definition, and first law of Newton. There are two parts in this chapter. First force and second part is laws of motion. In the laws of motion, we have three laws, three different laws. Here we did already the first law and we understood it in detail. After that we moved to second law. Second law, very little it remained, is that its application. In the last class, if you remember, I told one application that a cricketer is catching the ball with pulling his hands towards the body when he's completing the catch. That means he's increasing the time of receiving the catch. By doing that, the impact is very less, the force is very less on his hand. So this is the application of second law of motion. Okay. Similarly, there are other applications too. So second application, third application I'm going to do here. This is application of second law of motion. This was the topic we left in the last class. Number one I finished, and I'll discuss the second one that is given in your textbook too. You might have seen a karate player breaking a slab of ice with a single blow. He applies a larger force for a short interval of time, producing a large impact on the ice. Karate player increases the force by decreasing the time of impact. Suppose you think in the previous example, what he did is the fielder pulled the catch and increased the time of catching, then the force was very less. But you imagine now a karate player, what he does is he's going to break a piece of very hard brick. When he's going to hit it like this, just putting it like this, nothing will happen. If he does little harder, nothing will happen. But if he has to really break it, what he has to do is he has to complete the impact. When he touches the brick, it has to happen in very short time. If the time is very less, if the time of impact is very less, automatically the force will be very high. Okay, this is also the balancing between the force and the time, and that is what is second law of motion. Similarly, the third application given in the textbook is an athlete runs some distance before taking a long jump because this forward momentum may help him to jump longer. Athlete jumps, runs some distance before jumping. This is also an example of this second law, where the athlete is running for some distance, and then only he is increasing the impact. Okay, athlete is running some distance before actually jumping and covering that big distance. Similarly, fourth example given in the textbook is in a high jump event, athletes are made to fall either on sand bed or on cushion bed to increase the time of the athlete fall to stop after making the jump. High jump athlete are landing on soft ground. Okay, maybe there is sand or there is some cushion also in the international events you have seen, because when he is jumping high, he is increasing the force very much, and when he is going to land it, that means the force is going to be very high there. So that is why they want the time to increase the landing. When there is the cushion, a body falling on the cushion will complete his landing from here to here. Okay, it will be compressed. What he's doing, He's increasing the time of impact. If he does that, the force will be less because he has increased the T. Can you see? He has increased the T, so that large force will become small. Okay, because F into T has to be same every time. This is also the application of your second law. Similarly, there is the fifth one. Dropping anything from height will fall towards the earth. The force of gravity acting on the mass you drop produces an acceleration. This is a common feature. In the next chapter also we will do this. Anything dropped accelerates. This is a common feature. Anything you drop, its velocity will increase manifold. Okay, suppose it is dropping by 3 meter per second initial speed, it will become very high next second. Next second it will be very high. It will accelerate at 9.8 meter per second square. Almost 10 times every second it will increase. Okay, almost 10 times its speed will increase every next second when it is falling. Okay, so why this is happening? Because the time of impact will be, it is adjusted by the force, and here it is acceleration. Now, next topic is importance of Newton's second law of motion. I'm picking up all the topics according to your textbook, not from any other interest, just to complete your syllabus as much as possible. First is Newton's second law of motion concerns acceleration. It shows the relationship between the force and motion and allows us to calculate acceleration of the object with known forces. Number one, allows to calculate acceleration because it gives you the relation F is equal to ma. This is a good thing about second law. It provides explanation for the behavior object for which all existing forces are not balanced. Unbalanced forces explained. Third one, this law is valuable for scientists and engineers. They can find out the trajectory of the object at any given point of time by controlling measuring of force or by calculating the force exerted on the object. Now, force deciding motion is studied by this. This law is making it possible that we are able to understand that force has acceleration, and then that acceleration will give you the motion. Well, now it is initial motion, initial velocity, final velocity. All these relations we are very easily relating, because once you know the acceleration, that means you are already studying what v, u, all these are there. Okay, v, u, t, a already studied in your first chapter. Now we only introduced f. So f you know means acceleration is known. Once you know the acceleration, you are already going to study all these things. So these are the very powerful tools to study what will happen after some time, what will happen after that time. All these projections are studied by the second law from force itself. So these are the things that we have here. After this, we will go to some numericals. Okay, I'll stop the video for some time.